Hello everyone and welcome back to the CODEMAS. Today, let's briefly talk about dynamic programming. Dynamic programming is related to optimizing our work by memorizing, saving the previously calculated results. So, for example, imagine that we are about to create a monthly report and we need to track each day how many hours we have. So, for example, first day we have 8 hours, then we have 10 hours to two overtime and 8 regular, and so on. And after the first day, we have 8 hours. After the second day, we have 8 plus 10, 18 hours. Imagine that we have 162 hours, and on the last day, we need to calculate the total working hours. So instead of going from the first, second day, and so on, adding up all working hours, we will just use the previously calculated total and add today's hours to it. And it is our total. And in general, we are using some variable or some array to save previously calculated results. And we can have monthly report array to track the sum. Another example useful to illustrate dynamic programming is when we are about to calculate a Fibonacci number. First one is 0, second one is 1, and Fibonacci number is sum of previous two, n minus 1 and n minus 2. So we have 0, 1, their sum is 1. Now 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and so on. And if we are about to find nth Fibonacci number, first option is to use the recursion. So if we have the function f, we can have special cases. If n is 0, return 0. If n is 1, return 1. But in general, return f of n minus 1 plus f of n minus 2. Now let's see why this approach is not so good. So we have function f of n, and we are calling f of n minus 1 f of n minus 2. And let's take a look. If n is, for example, 8, we are calling f of 8. For that, we need f of 7 and f of 6. Further, for f of 7, we need f of 6 plus f of 5. So we are calculating f of 4 here, here, here. We are repeating the same call and we are applying the same calculation multiple times. And here is just the beginning of situation when n is equal 8. We didn't even finish this case, and imagine when n is equal 1000, which is still not so huge. So instead of applying this whole calculation, we can apply dynamic programming approach. We can create only one array of n elements, and first element is 0, second element is 1. And for each element from 2 up to n, we are calculating the element on index I using this formula. We know that 0 plus 1 is 1, 1 plus 1 is 2. And let's take a look at the same example where n is equal 8. We will have 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and 13. And we stop here. So this is a very efficient approach than using the whole recursion tree and calling the same function for the same value multiple times. That's it for today's lesson on dynamic programming. I hope this video helped you clarify what is actually dynamic programming and maybe helped you to try to use it in real life and in programming as well. Keep practicing and see you tomorrow with another topic.